x squared plus 8x equals 20. X squared plus 8x is greater than or equal to 20. As an equation, I'm going to move everything to one side, factor, use the zero product property to get that x equals negative 10 or x equals 2. I'm going to have to do the same for the inequality because it has x squared in it. But then I'm going to have to do something called interval testing. So I'm going to put the critical numbers on the number line. I'm going to test a number over here, something like negative 20. That will make the first parenthesis negative and the second parenthesis negative. Negative times negative is positive. No matter what number I'd chosen out here, it would have created a positive answer. Choose a number in here. Whatever number you choose, it's going to make this one positive, this one negative. Positive times negative is negative. Choose a number out here. Whatever number you choose out here is going to make both positive. Positive times positive is positive. I want the ones that are greater than or equal to 0. In other words, the two positive ones. So negative infinity to negative 10, and I can be negative 10 because I could be equal to 0, united with 2 to infinity. If I have fractions on either side of an equal sign, most likely I am going to take a cross product. So I'm going to get x squared minus 3x equals this FOIL problem, x squared plus 6x plus 5. I'm going to move terms to the same side. The x squared will cancel. I'm going to get 9x equals 5, x equals 5/9. That's lovely, that's easy, that's quick. When it's an inequality and I have denominator x's, I have to move everything to one side. Find a common denominator. My numerator, if I multiply this top and bottom by x minus 3, I'm going to get x squared minus 3x. If I multiply those together, my FOIL problem is going to end up with a negative running across it. So negative x squared minus 6x minus 5. So I've got negative 9x minus 5 over x plus 5, x minus 3 less than 0. So my critical numbers on a number line, well, for this, negative 9x minus 5 equals 0, negative 9x equals 5, x equals negative 5/9. Oh, whoops. That's funny. Negative 5/9 over here. Negative 5, negative 5/9, and positive 3. If I do the interval testing, and we have to be careful about it, but I'm going to tell you that I will get negative, I will get positive over negative, negative, so positive over negative, negative would be positive. I'm going to get a negative here when I do the testing, a positive here when I do the testing, and a negative here when I do the testing. The intervals I want are the negative ones. So my solution is negative 5 to negative 5/9, united with 3 to infinity. Again, this is going awfully fast. Stop the video anytime you want. If it's an equation like this, and I've got nice squares on both sides, I can square root both sides. I get x plus 4 equals plus or minus 3. So I get x equals negative 1 or negative 7. I cannot do it over here. I need to move everyone to one side. Plus 4 squared minus 9 is less than or equal to 0. I have to FOIL this out. X squared plus 8x plus 16 minus 9 is less than or equal to 0. X squared plus 8x plus 7 is less than or equal to 0. So I get x plus 1, x plus 7 less than or equal to 0. So on my number line I have a negative 7 and a negative 1. I'm going to do interval testing. Whatever I choose over here is going to give me, let's see, negative times negative, positive. In here I'm going to get positive times negative, negative. Over here I'm going to get positive times positive, positive. I want the ones that are less than or equal to 0. So I want this one only. So my solution is negative 7 to negative 1. Now I've got some straight equations. For this one, I'm going to cube both sides to free the cube root. 3x plus 8 equals negative 8. 3x equals negative 16. X equals negative 16 thirds. Again, isolate the strange thing and then undo it. This one's got fractions, although these two fractions have a common denominator. So I could subtract this fraction from both sides and end up with negative 2 is equal to x minus 4 over x plus 3. And then put this over 1 and do a cross product. So I could have negative 2x minus 6 equals x minus 4. I could end up with 3x equals negative 2. X equals negative 2 thirds. Okay, going on. This is an equation that even if I tried to factor it, I couldn't. So I'm going to need quadratic formula. X equals opposite b plus or minus square root b squared minus 4 times a times c. Minus 4 times a times c. So that's 184 all over 2a equals 14 plus or minus the square root of 12 over 2 is 14 plus or minus 2 root 3 over 2, which is 2 times 7 plus or minus root 3 over 2, and the 2's cancel. So I get x is equal to 7 plus or minus root 3 as my solution. Now I've got some random absolute value inequalities. When my inequality is less than, I can do it as a 3-part. Negative 7 is less than 1/2 x minus 3, which is less than 7. Oops. Negative 7 is less than 1/2 x minus 3, which is less than 7. Then I add 3 to all 3 parts. Negative 4 is less than 1/2 x, which is less than 10. And then I multiply all 3 parts by 2, so I get negative 8 is less than x, which is less than 20, which expresses this way. It's negative 8, parentheses, negative 8, 20. If it's greater than, I have to do it in 2 parts. There's a part that's greater than 7. Half x minus 3 is actually bigger than 7, so it's on the more than, distance is more than 7. But more than 7 could also be 1/2 x minus 3 is on the small side of negative 7, so it's going farther away from negative 7. So you get 1/2 x is less than negative 4, x is less than negative 8, you get 1/2 x is greater than 10, x is greater than 20. So I get negative infinity to negative 8 united with 20 to infinity. Okay, so that's